Hi everyone, my name is Abdul Samad. I am a mechanical engineer. Currently I am working as a maths tutor. For the last 3 years I teach in both offline and online mode. Due to the COVID-19 pandemic situation, now I am fully focused on online tutoring. You know, students from all over the world are learning through the online platform now. That's why I am focused on online tutoring. I have created a YouTube channel which is purely for educational purposes, and especially this channel will be useful for the students who are preparing for the competitive examination like KEAM, ncert, JEE main, etc. Okay. In this video, I would like to solve some of the model question for the KEAM examination. And their solutions in detail. So at the end of this lecture, you would be able to understand how a concept can be applied to different types of problem in a better way. Okay. Here I choose a topic. Here I choose a topic is straight lines, which is a chapter from your mathematics ncert +1 standard textbook. So those who want to look for is they can refer the textbook. Okay. Uh, this is very important chapter for the entrance examinations. In every year in the KEAM examination, you get 8 to 10 question, compulsory question from this chapter only. Also, this is one of the basic chapter in the area of coordinate geometry. Coordinate geometry, it's one of the main important area in the mathematics, which has got many real-time application. That's why this chapter is very important. We should have a thorough knowledge and concept for the all topics in this chapter. Okay. Let us move on to the questions. Now I am going to write the questions, and I will solve one by one. Okay. This is the first question. Find the length of the diagonal AC of a rectangle ABCD formed by the points A at 21, B 61, C A comma B, which is unknown, and D 24. Okay. We know this is the question from coordinate geometry and the chapter straight lines. So before we start, you should keep in your mind, before we start any problem from coordinate geometry, the first thing we need to make a rough sketch for the questions. Then you get a better understanding of the questions, then the problem solving will be very, very easy. Okay, now I am going to make one rough sketch. Let's see. This is x coordinate, x axis, and y axis. This is coordinates plane, xy plane. Okay. Now I am going to mark the given points in the coordinates planes. Let A would be somewhere here, 2, 1. And B would be at 6, 1 would be somewhere here. Okay. And C, which is unknown, leave that. D we can mark at 2, 4. 2, 4 would be somewhere here. Okay. Now I have marked the all 3 corner pointers of these given rectangles. We need to mark one more points which is unknown. So we will find it later. Let's please listen here. Okay. Now just join the points in order to complete the sides of the rectangle. Okay. Now we have got the 2 sides of the rectangle, which is AB and AD we have got. Now how do we locate the point C? Here we need to construct the full rectangle to get the answer. So how do we locate the points C? We know for a rectangle, using the property, we know the opposite sides are parallel. Opposite sides are parallel. So we can make a horizontal line from the point D parallel to AB. We can make a line parallel to AB from the point D. Similarly, we can make another parallel line parallel to AD. We can make from the point B in this direction. Now the intersection points of these 2 lines will give the coordinates, will give the point C. Now we have located the point C. Where is the exact location we have got? But still we don't know the coordinates of the points, the x coordinates and the y coordinates. Still we don't know. Now, how do we find out the coordinates? Here we use the concept of the condition of a line parallel to x-axis or y-axis. That's the condition we use here. See. Here, the line AB is parallel to x-axis. The line or line segment AB is parallel to x-axis. Why? For a line to be parallel to x-axis or a lane segment, here AB is a line segment. Line segment to be parallel to x-axis. Its endpoints will have the same y coordinate. That means it will have the same distance from x-axis. Means we know the y coordinates is the distance from x-axis. Here it is 1 and here also it is 1. So that's why when the distance from the x-axis to a line segment remains same, means the line segment is parallel. Similarly, the opposite sides are parallel for a rectangle. Then we can say CD also parallel to AB, and that means CD also parallel to x-axis. Okay. Similarly, when we look at the side AD has the line AD, the end point have A and D have same x coordinates. That means the distance from y-axis, x coordinate means what? Distance from y-axis, that is same for the points A and D. That doesn't change. That means this is the condition for a line segment to be parallel to y-axis, because the end points will have the same x coordinates, that will not change. So similarly, this y-axis and the line segment AD is parallel. Since it is a rectangle, AD also parallel to BC. So we can say AD is parallel to BC. Then we already know AD is parallel to x-axis. Then BC also parallel to y-axis. Okay. So this is the condition we use to find the coordinates of C. Then let's see how I am going to find out. See, take this line segment DC. Here the y coordinate is 4. For a line segment, this is, we know CD is parallel to x-axis. So to satisfy this parallel condition, the y coordinates of C must be same as the y coordinates of 4. So B we get 4. Okay. Then similarly, take the line segment BC, which is parallel to y-axis. So in order to maintain the condition of parallelism, the A must be the x coordinates of the B, because x coordinate of B must be equal to x coordinate of C. Otherwise, the line will not be parallel to y-axis. Now we have found the two coordinates of C, which is x coordinate 6 and y coordinate 4, using this rough sketch. Now what we are asked to find out the diagonal of a AC of a rectangle. Now this is the length AC we need to find. Okay. Now here we can use the formula, distance formula. What is distance formula? We know the distance between, let x1 y1 and x2 y2 are be any 2 points on a plane. Then the distance between these 2 points is given by root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula we use here to find the length of AC. So the same formula, how do we apply here? See, the distance AC we can find in terms of x2, here it is 6. For x1 is 2, 6 minus 2 whole square, plus y2 is 4 here, and y1 is 1 here. Okay. Now 6 minus 2 whole square, 4 square plus 3 square, that is equal to 16 plus 9, that is equal to 25, that is equal plus or minus 5. Here, since the length is a positive quantity, we take only the positive value. We don't take the negative value. So here we got the final answer. So the right option is option D. Okay. I think it's clear to you. Okay. Now this is a very simple question because the line segment AB or BC, AB is parallel to x-axis, BC is parallel to y-axis. So finding the coordinates of C is very easy here. Now I make some variations to the problem. I change the coordinates B and D such that the orientation of a rectangle in the coordinate plane becomes in the different direction. Okay, so okay. Let's see what happens if I make some changes in the coordinates. I keep fixed the point A, I don't change it. I change only the point B, 6, 3, and I change the point D. Okay. I have considered some variation to the questions. So the question what we are asked to the same final answer is find the diagonal of a AC. Question remains same, but only the coordinates I have changed. So let's see what would be the final answer here. Okay. Here A is at 2, 1. And B is at a 6, 3 would be somewhere here. Okay. B and D would be somewhere one. Now just join those corner points. To complete the rectangles, do the same procedure as in the previous example. Draw a parallel lines, and from here also draw a parallel lines. The intersection point will give the coordinates of the point C. Okay. Now this is the rectangle, new rectangles, which was formed by the new coordinates points. Okay. Here see, in the previous example, the line segment AB was parallel to x-axis. Here it makes some angle with the x-axis. So this is rectangle is tilted to different orientation. So here, if you look for to find the coordinate C, that would be very, very difficult because the point, the line segment containing this point is neither parallel to x-axis nor parallel to y-axis. So in this case, we cannot find the coordinates EC. We can find, but we need some angles. How much angle this line segment makes with the x-axis or y-axis? We need those angles, so we don't have. So we have to look for other solutions. See how I am going to do. Using the property of rectangle, we know all angles are 90 in the rectangle. Okay. Now what we need to find? We need to find the length of the diagonal AC. Okay. This is the length we need to get. Okay. Now here we use the Pythagoras theorem. Pythagoras theorem for a right angled triangle. What is Pythagoras theorem? If we consider in right angled triangle ABC, we can write Pythagoras theorem. AC square is equal to AB square plus BC square. So AC is equal to root of AB square plus BC square. Okay. This is the Pythagoras theorem we apply in this problem to find the length AC. But still we don't know the length AB and BC. How do we find the length AB and BC? Since the end points of the line segment AB are known, and BC means here AB is the length of the rectangle and BC is the breadth of the rectangle. So this is the breadth, this is the breadth, okay, this is the length, okay. So once we find the breadth from here using the distance formula, see AD is equal to BC. Since this is a rectangle, opposite side equal, so we can find out the breadth from here using the distance formula. The length AD, that is equal to breadth. Use the distance formula. 1 minus 2 whole square and y2 minus y1. y2 is 3 and y1 is 1. 3 minus 1 whole square. So we get minus 1 whole square plus 2 square. That is equal to 1 plus 4. It is equal to root 5. So we have got the breadth of the rectangle, root 5. Similarly, we can find the length using the distance formula. AB is equal to, L is equal to, AB is equal to 6 minus 2 whole square plus 3 minus 1 whole square. So that is equal to 4 square plus 2 square, that is equal to 16 plus 2 square root of 16 plus 2, that is equal to root 20. We can simplify it to 2 root 5. So we have got L is equal to 2 root 5 and breadth is equal to root 5. So here it is root 5, then here it also will be root 5 because the opposite sides are equal for rectangle. Okay. Now we can substitute the value of AB and AD equal to BC here to get the final answer. So apply the distance Pythagoras theorem. AC is equal to, okay, what is AB? AB we have got 2 root 5. 2 root 5 whole square plus BC is root 5. So root 5 whole square. We simplifying square root of 4 into 5 plus 5, it is equal to square root of, we take the magnitude positive, so plus 5. So the final answer, the diagonal length of the diagonal doesn't change. Only what is changing here, the coordinates of the points B and D. So the orientation of the rectangle is changed in the coordinates plane. So when you do some problems, try to do some of the variations to the questions. That will really help you to boost your creativity skill. Okay. Let us move on to the next question. is the question. Find the coordinates of the point P such that the points P comma Q divide the line segment OA joining the points O equal to 0, 0, O is at 0, 0 and A 30 to 0 in the ratio 1:2:3. Okay. Now, as I told you, make one rough sketch. Is x-axis and y-axis. Now we can mark the given points or the line segment OA, which is the end points at O equal to 0, 0 and A is somewhere here at 30 to 0. Okay. And to divide the line segment in the ratio 1:2:3, P and Q must be somewhere in the line segment, must lies on this line segment OA. Let it be P is here and Q is here. Let Q is here. Okay. Since these 2 points lies on the x-axis, the y-coordinates of this point is 0. So y-coordinate is 0. Now let x-coordinate of P is x1 and x-coordinate of Q is x2. And also given that this P and Q divides the line segment OA in the ratio 1:2:3. Okay, it is given. So we are asked to find out the coordinates of P only. So okay, let's see how I am going to do this. Here we use the concept section formula. Section formula. Section formula is used to find the coordinates of any point on a line segment. Consider a line segment AB with coordinates of A x1 y1 and x2 y2 in a prime. If we consider any inside point, let's say C, inside point which divides this line segment 1 m is to n, then we can find the coordinates of C using the section form. The coordinates of C are given by m into x2 plus n into x1 divided by n into x1 divided by sum of the ratios. Similarly for y coordinates, take m into y2 plus n into y1 divided by sum of the ratios. So this is x coordinate of the point C and that is y coordinate of point C. Okay, this same formula can be applied here to solve for P and Q. We can apply the same formula. Okay. Proof for this, if you want to see, refer some, you get the proof easily. You can prove this formula. Okay. Now here, first I take one line segment OQ and the internal point P. Okay, this is x1 0 and which divides 1:2 OQ. The line segment P divides the line segment OQ in the ratio 1:2. I take only this part. Okay, so here first I am going to apply section formula in this section. So the coordinates, x coordinates of P that is x1 is given by, take only the x coordinate m into x2. M is what? M is 1 and x2 is 1 into x2 plus n into x1, 2 into 0, because we know O is at 0 0 and Q is at x2 0. So 2 into 0 divided by m plus n. So we have got x1 is equal to x2 by 3, means 3x1 is equal to x2. This is equation 1. Here see, we have two unknowns x1 and x2 and only one equation. So we need two equations to solve for two unknowns. If we have three unknowns, we need three equations. Here we need at least two equations to solve for x1. So I take one more line segment PA, where Q is an internal point x2 0 and A is at 30 to 0 and P we know x1 0. Then we apply the same section formula for x2. So x2 can be written as, the division is, we know, 2 is to 3. Okay, 2 is to 3 is the ratio. Okay, so 2 into 32, x2 is here 32, plus 3 into x coordinate of p, 3 into x1 divided by sum of the ratios 2 plus 3. So we get x2 is equal to 64 plus 3x1 divided by 5. So 5x2 is equal to 64 plus 3x1. Now we have two equations and two unknowns. We know using the elimination or substitution method we can solve for this linear equation. Just substitute the value of 3x1 is equal to x2 from here to in this equation. So substitute 3x1 from equation 1 to equation 2. Then we get 5x2 is equal to 64. What is 3x1 here? x2. x2. So 4x2 is equal to 64. So x2 is equal to 64 by 4, that is 60. Here we are asked to find out x2 is the x coordinate of q. We are asked to find out the x coordinate of p, that is x1. So x1 we can find it from, once we get x2, because 16. What is x1? x1 is x2 by 3, which is equal to 16 by 3. This is x1. Now we have got the coordinates of p as 16 by 3, 0. So the answer is right option C. Okay. Let us move on to the next question. This is the question. Find the difference in y-intercepts of the lines L1 and L2 with slopes M1 and M2 respectively. Also given that the lines pass through a common point 4, 2. Okay. So make the rough sketch. Here it is given that line passes through a common point, so 4, 2 would be somewhere here, and we have two lines L1 and L2. First, I have drawn the line L1, and slope of the L1, sorry here not M1, slope is given 2 and 4 respectively. Slope of L1 is equal to 2, which I take because slope is represented by using the letter M. So for L1 slope is 2, and one more line which also passes through the same point. So let us strike. Okay. This is the line L2, and the slope for L2 is 4. Slope for L1 is 2. Okay. Now we need to find the difference. So first we need to find out the y-intercept for these two lines. To find the what is y-intercept? Y-intercept is the y-coordinates of the point on the line where the line meet y-axis. See here the line L1 meet y-axis here. So when we take the y-coordinates of the point, this point, let this point be A. When we take the y-coordinate of this point A, where the line meet x-axis, this y-coordinate is the y-intercept for this line. Similarly for the line L2, if it meet here, let B, the y-coordinate of B, that is C2, is this coordinates of this point would be 0, C2. Also this coordinate will be 0, C1. Since this point lies on the y-axis, the x-coordinate will be 0. Okay. Now we need to find the difference in C1 minus C2 to get the final answer. The options are given. Option A, 6, B8, C10, D12, E40. Those are the options. We need to choose the right option from by solving this. Okay. Now here we need the equations of a straight line in standard form. So there are many standard equations of a straight line in standard forms. So here we consider the equation. Slope is given and one point is given. So here we consider the slope point form. I think you might have studied what is slope point form. Slope point form. Slope point form of a straight line which passes through any point x1 and x2 and the slope m, and having a slope m is given by y minus y1 is equal to m into x minus x1, where m is the slope of the straight line and x1 y1 be the any point on the lines. So this form is applied here to find the equation for L1 and L2. Once we find the equation, we can easily find the y-intercept value. So for L1, line L1, apply the slope point form. Y minus y1 is 2 because these two lines pass through common point for 2. Y1 2. And m for L1 is slope for L1 is 2 into x minus x1 is 4. Okay, so y minus 2 is equal to 2x minus 8. So y is equal to 2x minus 8 plus 2. It is equal to y is equal to 2x minus 6. Okay, y is equal to 2x minus 6. This is the equation for line L1. Similarly for x2, for L2, y minus y1 is 2. M for L2 is 4. So 4 into x minus 4. Okay. So y minus 2 is equal to 4x minus 16. Y is equal to 4x minus 16 plus 2. So y is equal to 4x minus 40. So this is the equation for the straight line L2. Now we have got two straight lines. See, now from here we can find y-intercept in two ways. So let's see how I am going to. You know, this coordinates of the point is 0, C, C1. So this point must satisfy in this equation because all the points on the line L1 must satisfy this equation. So substitute the coordinates of A in this equation. Y is equal to C1, and when y becomes C1, x coordinate becomes 0 in this line. 2 into 0 minus 6. So C1 is equal to minus 6. Similarly, substitute for y-intercept for L2, C2 here, then x value becomes 0 at this point. So y is equal to C2 when we substitute y equal to C2. X coordinate becomes 0 because it meets y-axis, the line. C2 is equal to minus 14. Now we have got C1 and C2. So we can take the difference, C1 minus C2, that is minus 6. Minus 6 minus 14, that is plus 8. So answer is 8. Or also we have one more method, because this is the equations in the one standard form. Y is equal to mx plus c. Here y is equal to 2x minus 6. Okay, when we compare with this slope intercept form, this is slope and c is y intercept. So when we compare with this standard equation, we can directly get y intercept is equal to c is equal to minus 6 from here directly, because it's expressed in slope intercept form. That's why here also we can directly take the y-intercept as minus 14. Okay. Here I have discussed some of the model questions and the problem solving methods. Okay. This is only one session for this chapter. More session will be uploaded. Okay. I think you have understood all the explanation, all the concept and explanation which I have given here. If you have any doubt, please let me know your comments in the comment section, or you can reach me through my Facebook and WhatsApp links, which I have linked to this channel. Okay. I will be uploading more videos related to competitive examination in the future videos. So if you like this video, please like it and share to your friends. I am sure, no doubt, these videos will be very, very useful for your board exam and entrance exam preparations. Okay, so if you want to get all new videos on time, Please don't forget to subscribe the. Please don't forget to press the subscribe button and click the notification bell, so you will be notified with all new videos and you would not miss any new videos. Thank you. Thank you for watching me at Concept Maths Tutorial.